Hello, and thank you for watching this rules battery engineering training on YouTube. Appreciate your time. My contact information is Steve Higgins. I'm the Technical Services Manager for Rolls Battery. This is my contact information. All of my trainings are available both on YouTube and they are available on Google Drive. If you want to send me an email at steve@strat.com, I'll be more than happy to send you a link with of course, to the training. If you look below in the box, feel free to comment. If you rate this, do me a favor if you can. If you rate this, you didn't like this presentation, tell me why. That way I can fix it and make it better. Anyways, here we go. What we're going to talk about today is we're going to talk mainly about troubleshooting battery banks and what goes wrong with battery banks. I'm going to show you some pictures first, just to loosen people up a little bit, the fun pictures. And so this is an example of what we see a lot with batteries. Now, these aren't Rolls batteries. These are Hopeka batteries. Look at this tank. You see bus bars and connections here, 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 here. Haven't even had a connection made. This is a problem with the battery bank. Inside this battery bank, these connections are connected internally, but for the amount of current and the size of these specific batteries, all of the bus bars need to be connected. So this connection needs to be made, 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 and so forth. Without those connections, what will happen is the battery bank will develop problems. And if you notice, we go to the next slide, this battery bank has developed a problem. At one point in time, the connections were left loose. They probably corroded, and the terminal, the bus bar melted. So that is a problem. This is an example of another system. This is an example of a what we like to call a wives' tale. One of the wives' tales for battery banks, especially flooded lead acid batteries, is if you dump the acid out, you put new acid, the batteries will be just like new. Unfortunately, that is partially true. The batteries will come back, but what will happen is because you've introduced more sulfate into your batteries, because as a battery discharges, the sulfate populates on the plates, leaves the electrolyte, and then when you recharge, you push the electrolyte off the plates back into the electrolyte. By dumping this out, if there's any sulfate on the plates, then what will happen is that you'll introduce more sulfate into the battery, which will cause higher capacity, but it will also cause the battery to degrade faster. The battery degradation will accelerate as the battery goes. This picture is there's a lot of stuff going on in this picture. The number one thing I want to point out is they have a forklift style battery from C&D mixed with Group 31 style batteries. You cannot mix batteries. You can't mix manufacturers. You can't mix types. You can't mix capacities. And you want to try to avoid mixing ages of batteries as much as you possibly can. Doing so, what will happen is that the newer batteries are more resistive to voltage changes than the older batteries. And what ends up happening is that the newer batteries don't see as much of a charge, and it will cause failures. One of the other common problems that battery manufacturers have is people either have loose connections or they've over tightened the connections. If you look at this, you focus on this right here, your washers should not dig into the terminal that deep. This connection has been completely over tightened. You can see actually the concave connection right here. That's actually what's making connection to the washer or to the post, and it's not really producing a lot of energy or not conveying a lot of electricity. And so what ends up happening is it ends up being an over tightened connection. It basically acts just like a loose connection, and as you can see, the terminal has already started melting. You want to be careful with that. This is another battery bank. These are YS62 batteries. This is a picture that was sent to us, wondering why the battery bank isn't working. You do have to wire the battery bank completely to make sure that everything's correct. So, you know, just a little close-up, as you can see, there's not even connections on some of the positive and negative connections. So be careful of that. Everybody's heard this statement. We've said this 100 times. I've said it 1,000,000 times. Batteries don't die, they're murdered. Typically, most battery manufacturers have less than 0.25% or less failure rate for warranty. In general, most batteries are abused. The most common problem is undercharging. There's lack of maintenance. There's a whole host of things. And we're going to talk about this in the next 45 minutes to an hour or so. First thing I want to talk about is the chemical equations, basically how batteries work. Okay. On the positive, there's two different things that are going on between the positive plate and the negative plate. When you're charging the batteries, what's happening is that you're pushing on the positive plate when you're charging the batteries. What is happening is that we are taking lead sulfate plates in heavy water. You're forcing electrons through those plates. Basically, you have your electrons, and what's happening is you're pushing the sulfate off of the lead sulfate plates back into the electrolyte. So basically, what you're creating is PbO2, which is lead oxide, and the SO4 portion of that is going back into the electrolyte. So instead of having a heavy water, you now have H2SO4, which is basically your electrolyte acid mix. On the negative plate, when you're charging, basically what's happening is the same thing. Is you have PbSO4, which is a lead sulfate plate, and you're pushing and you're creating, of course, sulfuric acid or the electrolyte, and you're creating a lead plate. So as you are discharging the battery, the sulfate is populating on the plates, and then you're recharging, you're pushing that sulfate through a chemical reaction back into the electrolyte. It's important to understand that, because one of the first questions that most battery manufacturers, especially for flooded battery manufacturers, will ask is, what are your specific gravities? That tells the battery manufacturer how much sulfate is on the plates versus how much sulfate's in the water, and it allows us to advise you that your charging settings may be too high, they may be too low. Every system is different, and so you need to make sure that you're charging correctly. Most common causes of failures. Number one cause of failure is undercharging. That's the number one cause of failure for all battery bank systems. This is, I would say, 85 to 90% of the phone calls that I deal with here at Rolls, and talking to other manufacturers, it's about the same. Most customers are not properly charging their batteries because most customers don't understand that solar, in general, 4 to 6 hours, if you don't have a tracker, is your maximum window for charging. If you don't have a large enough array, if you're not in that 10 to 15 to 20% charge rate, you just don't have enough array to get those batteries to a full state of charge, especially if you're using loads during the day. People run air conditioners, they use a lot of loads during the day. They call problems. They have problems. Excessive heating. Heating's another huge cause of failure for battery banks. You know, you see some freezing issues, but heating is a problem, because with any lead-based battery, with any battery, over temperature, overheating of the battery will cause the battery to break down earlier and cause a problem with the specific battery. Flooded lead acid or lead acid batteries alone, they're supposed to be operated at 25 degrees Celsius or 77 degrees Fahrenheit. A 10-degree swing from 25 to 35 degrees Celsius or 95 degrees Fahrenheit, 97 degrees Fahrenheit, what will happen is you lose half of your capacity or half of your cycle life, okay? So you're going to lose half your life cycle just by having the battery at that higher condition. If the batteries are installed in a location where they're constantly hot 12 months of the year, you are losing life cycle on those batteries, and they won't last as long as you think they're going to last. Lack of water or poor maintenance. Just yesterday, I spoke to a customer who has had his battery bank for 5 years, and he's never taken a specific gravity reading. How does he know he's ever properly charged those batteries without looking at the specific gravity? On flooded lead acid batteries, that's imperative. You have to do that. Last but not least, overcharging can be an issue. It's the least common issue. You typically don't see it. A lot of times you see it mostly on AGM batteries. You see it on flooded batteries when customers aren't properly using their battery temp sensors. Something to look at. Some troubleshooting symptoms. Here are the most common symptoms for battery banks: lack of capacity, longer than normal generator run times, excessive or no water use, imbalanced cell heating or excessive gassing. Or specific gravity readings inconsistent or very low. This is a good example of a battery here. This battery specifically, even with if you look, the batteries in general are all pretty well beat up. There's evidence of overflow, of basically overfilling the batteries, evidence of a lot of heat. This battery, this particular cell alone is basically failed. It's done. Is this a warranty? No, it's not. This battery bank's been abused. It hasn't been taken care of properly, and that's why it's not covered under warranty. Specific gravities in general. This is a general specific gravity chart. On Rolls batteries, we want to see your specific gravity for a full charge depends on your use. This chart says 1255 to 1275. Okay. For a industrial or a motive application, like a rail application or an industrial application where the customer is seeing 8, 10, 12, 14 hours of charging every single day, you can run a little lower specific gravities. On a solar application, because you're only seeing 4 to 6 hours of charging on average every single day, in some cases in the winter that might be 1 or 2 hours. In the summer it might be 5 or 6 hours. Depending on what the array is doing or what's going on in the system. We want to see a little bit higher specific gravity, which will give you a better capacity. So this is a specific gravity chart to give you an idea of what's going on with the batteries. There's ranges. You want to take those ranges in effect when you're taking a look at the batteries. Okay, this is one of the charts that I don't like very much, and the reason I don't like it very much is because a lot of people only look at voltage to depend on what their state of charge is. Voltage is the absolute worst way or method that you can use to measure your specific gravities or your state, to check your state of charge, because it depends on how much load's running on the system and the current health of the batteries. If your batteries are in a sulfated state, these voltages are going to be through the floor, and you're not going to be able to tell what's going on with your batteries. The other problem is it depends on the amount of load. So generally, open cell voltages are the easiest way to do this. Basically, these are the voltages that you would look to see for a fully charged 100% battery at rest open cell for 3 hours. How many of us in an off-grid system are going to disconnect our batteries for 3 hours and let them sit so we can measure voltage? It's a lot quicker, a lot easier to take a hydrometer or a refractometer and measure your specific gravities, log them, and then change your voltage-based parameters based upon those set points. These settings, 75, 50, 20, and then 0%, these are based at a C10 discharge rate, basically, which means you're loading the batteries at the 10-hour rate, and you're measuring your voltages as you go for your state of charge. Be very cautious of using this chart. It's not the best thing to use. I would try to avoid this as much as possible unless you're doing a load test. Sulfation. This is the definition of sulfation. I'm not going to read it to you. You can pause the video and read it if you wish. Basically, what sulfation is as the batteries have sat in a discharge state, what will happen is the sulfate, the SO4, and the electrolyte will populate itself on the plates. If you leave that sulfation on the plates for more than a month or more than 2 months, what will happen is that sulfate will crystallize, it will harden, and it becomes very difficult to remove that sulfation. This is why it's imperative that when you are charging your batteries, that you are getting your batteries to a full 100% state on a 7 to 10 business day or 7 to 10 days, especially on systems where you're doing heavy cycling. If it's a light cycle system, that can be 14 to 28 days, but at least once a month, you have to get your specific gravities up to that 1265 to 1275 range. Here's a picture of what sulfation looks like. The next few slides are pictures of what sulfation looks like on plates. This is a plate that was pulled out of a battery. This white area is all hardened sulfate. What's happening is it's hardened on the plate. It's not going to come off. No matter how much equalizing you do, no matter how much charging you do, it is not going to come off. This is a well-formed positive plate. You can see a little bit of sulfation along the edges, a little bit of sulfation, a little bit darkening. It's about a 10-year-old plate. It's pulled out of a set of batteries that were 10 years old, just to show you an example of what it looks like. Here's some more sulfation, a couple different varying degrees of sulfation. You got the sulfation in the middle here. You got a little bit of sulfation on the plates here. Again, this is not a manufacturing defect. These defects are caused by undercharging on the battery bank. Sulfation is caused by lack of proper charging in the battery bank. That is not a manufacturing defect. That is a defect in the system. That is a defect in the education of the customer. That is a defect in how the customer is maintaining and taking care of their system. Something to know about sulfation, a little bit of a pop quiz. If I took a 55-pound lead ingot and dropped it in a 55-gallon bucket of water, what would happen? Well, over time, that lead brick would dissolve. And that's a secondary issue with all lead acid, especially flooded lead acid batteries. When you have a flooded lead acid battery and it sits at a low specific gravity, basically water for a very long period of time, they've been consistently abused, you actually start to lose plate material. That loss of plate material starts to cause problems with the batteries, and it will kill the batteries. It will cause you capacity problems. It'll cause you problems as the batteries age. So symptoms on sulfation during charging, typically what happens is a bulk charge phase. Voltage per cell or voltage on the battery bank is going to rise very quickly. Specific gravities are all going to consistently be low, and your extended period of low specific gravities will cause large differences between specific gravity readings. So the longer it's there, the more damage that you're going to see. We'll talk about some specific gravities here in a bit and examples of this. How to fix it? You have to have proper bulk absorption voltages. You have to make sure you may need to extend your absorption times. You need to figure out a way to force your charge controllers or your inverters to charge those batteries correctly. Of course, you can also use corrected equalizations to speed the process up. But again, equalizations tend to cause high temperatures. Those high temperatures will also lead to the batteries prematurely failing. Preventative measures for sulfation. Record and retain specific gravity readings, at least quarterly. If you have a single string of L16 6-volt batteries, measure the odd number of cells on the odd month, measure the even number of cells on the even months. If you have 2 or 3 parallel strings of batteries, measure one string a month, and that way you, over a quarter, over a 3-month period, you have a full recording of specific gravities. Ensure you've got your proper bulk and absorption voltages. Make sure you're using temperature compensation. Ensure your absorption times are correct. Manually verify the battery achieves 100% state of charge every 7 to 30 days. Again, the heavier you cycle it, the more often you need to be at that full state of charge. The lighter you cycle that battery bank, you may do the lighter cycling, you can extend the full charge times up to 28, 30 days. Cell heating. Cells should heat relatively even across the battery bank. They should be within 2 to 3 degrees Celsius for they're well under charge. It's a good idea to use an infrared temp sensor or a FLIR camera to measure cell temperatures and look for large differences. In this particular case, this battery bank, we have a battery here that's probably got a manufacturing defect or a shorted cell internally. That is a problem. We look at this battery bank here, cell heating across the batteries isn't truly constant. This battery is hotter than the rest of the battery bank, so it's actually showing some sulfation. And we're also seeing some poor connections on the battery bank, which could be causing sulfation problems with this specific battery. So cell heating's a problem. Another thing that can, if you don't have a camera, another thing you can look at is water use. Lack of or excessive water use indicates possibly a failed or a shorted cell. Cells that are in the open condition will hardly bubble when being charged. Shorted cells will bubble like you're boiling an egg. It is natural to see the electrolyte boil, okay? It's gonna bubble. That's the gassing. That's mixing up the electrolyte. It should be relatively uniform throughout the entire battery bank. But it's not gonna be exactly the same for all of them. I get a lot of calls from clients or customers saying, yeah, my battery bank is boiling away. I'm afraid I'm going to use electrolyte or use water. Water is cheaper than buying lead. So it's cheaper to charge the batteries than to replace the batteries with new batteries. Just to give you an example of an overcharged or overheated battery, this is a typical 10, 15-year-old battery. The oxide's dark, the lead oxide's dark. It's got a little bit of scarring, but the active material stayed with the plate. This plate here, you can see the active material is actually cooking away from the battery. That indicates that the battery is basically being overcharged, over temperatured, and basically that active material is being cooked off the grid. The next picture is a picture of a hydrometer. This is an easy red hydrometer. Honestly, it's not the best hydrometer in the world. A lot of people have this because it's a cheap, less than $10 hydrometer. It's easy access. Most places have it. You have to be careful with this hydrometer because you have to flush it with distilled water after you're done. Not after every cell, but after you're done and before you're going to store it, I would flush it with distilled water and put it in a 1-gallon Ziploc bag, or take an old distilled water canister, make sure it's clean, and cut the top off, store the hydrometer or your hydrometers or your tools in there, and then put the top back on so that dust and dirt and stuff stay out of your batteries. This is an example. If you can see, this is active material that's coming off the plates that's floating around the battery. This is caused by excessive temperatures. Could also be caused by overcharging issues. This battery here, your electrolyte should not look like weak tea, weak coffee, or chocolate milk. This tells me the battery bank has been seeing excessively high temperatures, and the battery bank's either been overcharged or the temperatures are getting really, really high. Or the battery may just be close to end of life. This particular battery bank was actually installed outside on the west side of a house in the eastern Oregon, where the temperatures ranged from 125 degrees Fahrenheit in the summer to negative 30 degrees Fahrenheit in the winter. And so this battery bank had seen some pretty wide temperature extremes. Last but not least, this doesn't happen with too many Rolls batteries, but acid stratification. A battery that sits for a long time and doesn't properly charge, what will happen is the electrolyte will stratify. The acid, which is heavier than water, sinks to the bottom of the battery, and the water floats on top. What can happen is it'll cause battery capacity losses due to excessive corrosion. What you'll see is the acid will settle onto the bottom, corrode the bottom of the plates, and cause problems. With Rolls batteries, this doesn't happen to us very much because we use about 96%, a little under 95.78% lead and about 4.25% antimony in the battery. What the antimony does is it lowers the overall gassing point of the battery and causes the battery to bubble earlier, which helps stir up that electrolyte, which keeps it from having too many problems. So following, we're going to do some troubleshooting examples. Mixing batteries, older and newer batteries. Again, older batteries will be less resistant to voltage changes. Okay, I've said that a few times during this presentation, during this talk. What that causes is voltage is going to rise much faster than when the batteries were new. Newer batteries are more resistive to voltage changes. Okay, so the voltage doesn't rise as fast. So When you take a 2 or 3 year old battery bank and you throw another parallel string of batteries at it, what will happen is over the first 4 or 5 or 6 months, those newer batteries are going to sulfate to the level of the old batteries. If you then take another set of batteries 3 years down the road and throw them in there, what's going to happen is that the new batteries are going to become like the old batteries within the first 4, 5, 6 months. So just be prepared for that. Make sure it's something that you don't want to do. Battery manufacturers will not warranty batteries for capacity and many other problems if you're mixing older and newer batteries, especially when you start getting over 6 months to a year old. If you mix a battery bank, say a string of S550s that are 6 months old with a string of S550s, 3 years down the road 3 or 4 years down the road, you put in a parallel string, you avoided the warranty on that new set of batteries basically as soon as you put in there, at least for capacity. Because what's going to happen is those new batteries are going to sulfate to the level of the capacity, the lowest capacity in the battery bank. So be careful doing that. You don't want to do that. When a battery manufacturer replaces a battery, say you have a string of 16 S550s or 2 strings of 16 S550s, and replace 1 or 2 batteries due to a cell failure or a warranty issue, we're sacrificing that new battery to keep the old battery bank alive. We know that. That's why battery manufacturers don't swap out entire batteries. Preventative maintenance, logging data is very important, especially with flooded lead acid batteries, but it's also important with AGM or valve regulated batteries. There are, you can take voltages under load, you can take voltages at rest, especially for AGM batteries. It's part of the maintenance of taking care of a battery bank. There is no such thing as a maintenance-free battery. That is marketing mumbo jumbo, and it's to sell batteries to customers who don't want to do any maintenance. There is always some sort of maintenance to do with a battery, especially if you flooded lead acid batteries. You're checking connection, you're checking you're checking your ventilation, you're checking your specific gravities, you're adjusting your charging set points. AGM batteries, you're checking your open cell voltages, you're checking your loaded cell voltages. Maybe you're doing a load test with batteries once every year. I would strongly advise for that. So logging your data is very important. When you start troubleshooting a battery bank, the process can be 1 or 2 days. It can be 4 to 6 weeks. I currently have tickets that have been open for 6 months that we are currently working on troubleshooting, verifying issues, and taking care of issues. So just be prepared for that when you start talking about troubleshooting. Troubleshooting batteries is not like troubleshooting an inverter or a solar charge controller. There are a lot of variables to troubleshooting and a lot of variables that batteries can't control that you need to address. Generally, most battery companies have very low failure rates. Typically, for Rolls battery, we replace about 1% of our annual production of our battery under a warranty or a gratis warranty. Realistically, of that 1%, about 0.20% of those batteries are actually a manufacturing defect. So that means it's actually a lot higher than this 1 in every 1,000. It's actually about 1 in every 3,000 or 4,000 batteries actually has the failure. Installers and users should have the tools and the education to properly troubleshoot the battery bank. Too many people swap out batteries that are fine but are just undercharged. I have talked to hundreds of customers in just the past couple months, and I can't tell you how many of those customers, when I asked them what their specific gravity was, or what their voltage was, they didn't have a voltmeter or a hydrometer. Okay, you need to have that equipment to be able to troubleshoot, and you need to spend some time and learn how to troubleshoot and how to do your. I mean, the troubleshooting is just basic maintenance. Taking a look at your basic maintenance. So you need to do that maintenance. You need to have that education to be able to properly troubleshoot the system. Okay, so now we're going to talk about interpreting specific gravity measurements. Okay, again, thanks for holding on. This is a lot of information. I'm going to try to get through it as fast as possible. We'll probably got about another 30 minutes left of this. 25, 30 minutes. So this battery bank is 12 cells. They're 2-volt cells, so it's a 24-volt battery bank. Okay. Um, I get these every once in a while where a customer will report, I got 270, 270, 270, 270, 270, all the way across, 260. All the specific gravities are all exactly even. How often does this really happen? Never. It's not. And usually when you see this, it becomes a red flag. And you get one, a lot of times we'll get a specific gravity that's, 1140 or 1120 or 1100, and all of them will be 1265. That's typically a red flag. It's not normally what you see. What you normally see is you see something like this. You see a 5 to 10 point spread between all the specific gravities, because every single battery, although we do our best to make sure the batteries are exactly the same impedance, internal impedance, there's going to be little differences between every single battery that is manufactured, regardless of who makes the battery. So this is what you're normally going to see. Something like this. This is most common. So 10 to 15 point difference between specific gravities. That's your meter. That's batteries. That's a lot of different things. On this battery bank, this is a specific gravity reading. We got 268, 265, 210, 260, 265, 266. So this is typically what you see when you have a cell that is in the process of failing. Okay. But there's some troubleshooting that we need to do. Basically, cell three is showing signs of sulfation or increased resistance. Okay. How would we attempt to fix this? First thing I would do is I'd advise the customer to check and clean the connections. Okay. This means shutting the battery bank down, pulling your connections, taking a little bit of what I'll do is I'll take 1 part baking soda, 2 parts warm water with a warm rag, with a rag, and you take it, you dip it into it, and you wipe down all the connections, and then I'll take a file over a rasp or some coarse sandpaper and clean off the battery terminal. Let it dry out, wipe it down with distilled water, and then remake your connection, and then put your connections back together. Put a little bit of petroleum jelly or dielectric grease. A little bit goes a long way. Don't just spray or glob it on, and then recheck it. Okay. Something else you can do, if you're not already at the top end point, raise your bulk and absorption voltage by 0.2 or 0.4 volts DC, or add 30 to 60 minutes to the absorption timer. Okay. If you do that, what you do, of course, if you have a partially sulfated battery bank, defeat your indamps temporarily. Run it for 2 or 3 weeks and see what you get. Okay. Wait 2 or 3 weeks, 3 or 4 weeks. Okay. So let's say you get this. The specific gravities and the rest of the cells all bumped up. Okay. Except for that one cell. It stayed the same or got worse. Okay. At this point, if you're troubleshooting with me at this point, I'm probably going to replace this battery. Okay. Or this specific cell. You could try an equalization. But an equalization will probably just raise these other specific gravities, the other 11 cells higher, and that may cause you even more problems. So at this point, I would probably just replace this cell, and if it's less than the warranty period of the battery, we replace it under the warranty. If it's older than the warranty period of the battery, and this starts to happen, it might be a sign of end of life on the battery bank, where individual cells start to drop out. So if you get this, if you've been 3 or 4 weeks and you see a 30-point rise, and that one battery rises in specific gravity, the rest of the batteries kind of rose a little bit, this means it was a connection issue. This means that it wasn't a battery issue. This means it was a problem with the connections and with the maintenance that was being done on the system. In this particular case, I would not replace this battery under warranty. This battery was probably damaged because of a connection issue, or it was damaged because of a charging issue. And then, of course, that is not a warranty failure because it's not a manufacturing defect. 220, 230, 225, 227. Basically, all the batteries are within 5 to 10, 15 points of each other, but they're all just low. What's the problem here? Well, the problem with this battery bank is that the battery bank is becoming undercharged. Basically, your customer is overusing the battery bank, or your customer is not charging the battery bank, or the charging settings aren't correct for how your client is using the battery bank. Okay, so how do you fix? Okay, again, you go back through, you check and clean connections, you raise your bulk and absorption voltage by 0.2 or 0.4 volts, and you add some time to your absorption timer. You defeat your end amps because the battery bank, again, is partially sulfated. Your end amps is going to cause problems with that. Okay, and then you wait a few weeks. All right, wait 2, 3, 4 weeks. If you get this, 252, 255, basically, it's obvious your customers were undercharging the battery bank. The problem is that because the batteries were in a sulfated state, you may not get the batteries up into that 1265 to 1275 range because the batteries have already been abused. They've already seen some sulfation. That sulfation may have hardened. On this particular battery bank, I personally wouldn't try and equalize on the battery bank because it may cause more damage than good. It may overheat the batteries and accelerate cell failure. So you want to be careful with that. This battery bank, 228, 240, 250, 215, 267, 250. Basically, we have a wide varying range of specific gravities. Again, this is a battery bank that has been chronically undercharged for a long period of time. You have started to lose capacity because of excessive sulfation. You have started to lose capacity because of loss of plate material or loss of active material on the plates. The battery bank has seen problems. The first thing I would do here, again, this is going to sound like a broken record. I would start with a little more aggressive charging. Again, I would raise my bulk and absorption voltages, defeat my end amps, and then I'd wait 3 or 4 weeks. Okay. The reason is that the batteries are going to respond better to a longer, lower charge voltage than a shorter, higher charge voltage, such as an equalize. Okay. So here, 3 or 4 weeks, your specific gravities come up. Okay. They're still not perfect, but they come up. And so what I would do in this, I would keep the end amps defeated. I would try a short 1 to 3 hour equalization of between 2.55 to 2.6 volts per cell, roughly about 31.2, 30.5 to 31.5 volts. The damage to this battery due to sulfation is going to probably remain. You're going to fight this battery bank probably for the rest of this battery bank's life, especially these low cells, cell 4, cell 9. Those lower cells are probably going to be low for the balance of the battery bank. There's not a whole lot that you can do about it. If after 3 to 4 weeks you get some improvement, okay, but it's not perfect, at this point in time, I would go with a little bit longer equalization at that roughly 30.5 to 31.5 volts. Let the battery, don't do back-to-back equalizations. Do an equalization, give it 2, 3, 4 weeks, and then do another equalization. Okay. If after 4 or 5 or 6 months, 5 to 7 months here, the damage and these don't come back, the damage probably is not going to be repairable. Okay. Probably not going to be fixable. The battery bank sat in a sulfated state for way too long. At this point in time, if you're an installer, at this point in time, you're going to advise your client that the battery bank is probably close to end of life. Okay. If you're a homeowner or end user, you better start saving your money because your battery bank's probably within 6 to 18 months of failing. So you want to be careful with that. Again, this kind of stuff is not covered under warranty. This kind of stuff is not a manufacturing defect. It's a charging problem. It's a maintenance problem. It's manufacturing defects cover manufacturing defects. They don't cover customer abuse or lack of charging. This is a pretty common one I see. Unfortunately, I probably see these specific gravity records from clients twice, maybe 3 times a week. Basically, you use 1180, 1190, 1185, 1200. You've got a 20, 30 point swing, but they're all sitting around between 50 and 70% stated charge for the battery. These batteries are exhibiting extreme signs of sulfation due to severe over discharge or undercharging. They're both the same thing. If your customer over discharges the battery bank, that's the same thing as undercharging the batteries. So again, we're going to get a little more aggressive with this one because we need to recover these as soon as possible. Raise bulk or absorption voltage by 0.4 to 0.8 volts DC. If you cap out, you don't want to really go above 30 volts on this one. If you cap out, then you extend your absorption time. You must defeat your end amps, and then you'll wait 3 or 4 weeks. I would probably monitor it during those 3 or 4 weeks. Just spot check the cells and see where they're going. I would make sure that the batteries aren't overly gassing or gassing too much. And make sure that when you are charging at these higher voltages and you're charging at these longer times, that you do increase the amount of airflow within the battery room to make sure that you don't have any hydrogen ignitions. If after 3 or 4 weeks you get these readings, you've seen some improvement. Okay, it's not perfect. You see how these are actually live specific gravities. I pull a lot of these specific gravities from banks that I've troubleshoot. You've seen some improvement, but it's not perfect. Again, you keep the end amps defeated. You could try an equalization, but I would probably let it run for, another 3 or 4 weeks, and see where it's going. Your results should get better and better and better. You could accelerate that by equalizing the batteries. It depends on the customer. It depends on the client. So if after 3 or 4 weeks you get these readings, basically you saw a little bit of improvement, not much. At this point in time, I would probably try an equalization. If the equalization works, great. If it doesn't, if you get this, the battery bank's done. It's been abused or at a low state of charge for too long. There's really nothing that you're going to be able to do. The battery bank is at end of life and should be replaced. Your customers could probably use it for a short period of time, but they're going to notice that their battery bank capacity is just not there where it should be, and they're going to be running their generator or charging a lot to get those batteries to a full state. Okay, well, I want to thank you for listening. Again, if you put this presentation is available. Of course, you're watching it on YouTube. The PDF of this presentation is available on my Google Drive, as are all of my presentations. Just remember, these are living presentations, so there's a history of presentations. You always want to try to look at the newest dated one. If you have any questions, you can feel free to send me an email direct, or you can post it on YouTube. I'll be happy. I keep an eye, about once a week I check those just to make sure I'm keeping up on them. If you like the video, great, tell me you like it. If you didn't like the video, even better, let me know what I did wrong or what I forgot, or I'll be more than happy to take any kind of criticism you want, either destructive or constructive, preferably constructive, and I'll be happy to do what I can to make this presentation better. Just putting a dislike doesn't help. Just let me know. If you put a dislike, make sure to put a comment on there. Make sure, or send me an email direct and say, Steve, you could have done this. It could be greatly appreciated. Thanks for watching. You have a good day.